Good morning, children, and welcome back to the physics online classes. Today, in this video, I'll give you a revision of chapter Magnetic Effects of Electric Current. What are magnets? As you know, a substance which attracts small pieces of iron and points in north-south direction when suspended freely is known as a magnet. A magnet can attract small pieces of iron, nickel, cobalt, etc. Okay, and when you suspend it freely, it always points the north-south direction. Such a substance is known as a magnet. Okay, a naturally occurring iron ore, which is called lodestone or magnetite, is always behaves as a magnet, but it is a very weak magnet. The one we see are made from them in artificial way and permanent and strong. Okay. Now, what are the properties of a magnet? A magnet has two poles, that is a north pole and a south pole. Like poles repel each other and unlike poles attract each other. That means a north pole repels a north pole and a south pole repels a south pole, but a north pole attracts a south pole and a south pole attracts a north pole. Okay? They always exist in pairs of poles. If you go on dividing the magnet, each piece will have a north pole and a south pole. Okay? It always exists in pairs of poles. Repulsion is the only sure test for a magnet. So these are the properties of a magnet. Here you can see the diagram of two magnets. The first one is called a bar magnet, which is rectangular in shape, and the second one is a U-shaped magnet. Clear? Now let us see what are magnetic fields and field lines. Magnetic field means the region around a magnet where the force of attraction or repulsion can be detected. We have seen that in the properties of magnet, there is a repulsion between the same poles and attraction between the opposite poles. So the magnetic field means the region around a magnet where the force of attraction or repulsion can be detected. Magnetic field around a magnet can be detected by using a magnetic compass. Okay, here you can see the diagram of a compass. It has a needle. Okay, it always points the north direction. Now, what are magnetic field lines? Magnetic field lines are the paths around a magnet along which the north pole of a magnetic compass needle tends to move. What are magnetic field lines? They are the paths around a magnet along which the north pole of a magnetic compass needle tends to move. Okay, the magnetic field lines around a magnet can be observed by sprinkling iron fillings around a magnet. One activity is given in your textbook uh, related to this topic. Okay, just go through that one. It can also be observed by moving a magnetic compass around a magnet. What are the properties of magnetic field lines? The magnetic field lines emerge at the north pole and merge at the south pole. Okay, it starts from the north pole and ends at the south pole. The magnetic field lines are closer at the poles. and the magnetic field lines do not intersect each other. So these are the properties of magnetic field lines. Once again I will repeat. Magnetic field line starts from the north pole and ends at the south pole. Magnetic field lines are closer at the poles and they never intersect each other. They will not cross each other. Okay. You can see the figure of magnetic field lines. Okay. See, these field lines are starting from the north direction and ends at the south pole, and at the poles the magnetic field lines are very closer to each other and they do not intersect each other. Okay, our next topic is magnetic field due to current carrying conductor. If a magnetic compass is placed near a conductor carrying current, the needle is deflected. If we place a magnetic needle near a conductor carrying current, you can see a deflection in the magnetic needle. Okay, what does it mean? It means that the conductor carrying current has a magnetic field around it. That means a current carrying conductor behaves like a magnet. That is why the compass needle shows deflections. Okay. If the direction of the current is from north to south, the deflection of the magnetic needle is towards the east. If the direction of the current is from south to north, the deflection of the needle is towards the west. Okay, so the direction of deflection depends upon the direction of the current. Clear? The magnetic field around a current carrying straight conductor is in concentric circles. See the figure. Okay, what is the shape of the magnetic field lines around a current carrying straight conductor? It is concentric circles. Concentric means circles which is having the same center. Okay, it can be observed by passing a current carrying straight conductor through a cardboard and sprinkling iron fillings on it. Now, what is right hand thumb rule? The direction of the magnetic field around a conductor is given by the right hand thumb rule. Using the right hand thumb rule, you can find out the direction of the magnetic field around a conductor. We have seen that a current carrying conductor behaves like a magnet. So the direction of the magnetic field around the conductor is given by the right hand thumb rule. Okay. Now what is right hand thumb rule? According to this, if a current carrying conductor is held in the right hand such that thumb points in the direction of current, then the fingers wrapped around the conductor shows the direction of the magnetic field. See the figure. If the thumb of your right hand points in the direction of the current, then the fingers wrapped around the conductor shows the direction of the magnetic field. Clear? Now, what about the magnetic field due to current in circular loop? What is a circular loop? Circular loop. You can see the diagram here. Okay. When current is passed through a circular conductor or loop, the magnetic field produced is in the form of concentric circles around the conductor. Towards the center, the arcs of the circles become larger and appears as straight line. So this is the diagram of the shape of the magnetic field produced by a circular loop. They are concentric circles around the conductor. Okay. These diagrams are very important. You have to draw and practice. The next one is magnetic field due to current in a solenoid. What is a solenoid? A solenoid is a circular coil of wire in the shape of a cylinder. You can see the diagram of a solenoid here. Okay, this is a solenoid. Solenoid means it is a circular coil of wire in the shape of a cylinder. Okay. When current flows through a solenoid, it behaves like a bar magnet, as I told you. The ends of a solenoid behaves like the north and south poles of a magnet. The magnetic field produced by a solenoid is similar to the magnetic field produced by a bar magnet. That means it starts from the north pole and ends at the south pole. The field line starts from the north pole and ends at the south pole. Okay, so the magnetic field lines produced by a solenoid is just like the magnetic field lines produced by a bar magnet. And you can increase the strength of the magnetic field by increasing the number of turns of the coil. If more number of turns, the strength of the magnetic field will be more. Okay, so the strength of the magnetic field depends upon the strength of the current and the number of turns of the coil. Also, you can increase the strength of the magnetic field by increasing the strength of the current. Clear, children? Now, what is an electromagnet? A strong magnetic field inside a solenoid can be used to magnetize a piece of magnetic material like a soft iron when placed inside the coil. Such a magnet is called an electromagnet. Electromagnet means magnetized material like a soft iron when it is placed inside the coil. Okay, or we can say the magnetism produced by passing electricity through a substance. It become an electromagnet. Okay, if electric current is passed through a wire wound around a piece of soft iron, it behaves like a magnet. Such a magnet is called an electromagnet. Okay, when electric current is passed through a wire wound around a piece of soft iron, it behaves like a magnet. Such type of magnet is called an electromagnet. You can see the diagram here. If you wound copper wire over a iron nail and pass electricity through that one, it will behave like a magnet. Okay, that is an example of electromagnet. So this is the end of today's video. Go through the portion, read the chapter nicely and understand it. Rest of the chapter I'll explain in the next video. Till then, thank you, bye bye, and take care.